in lecture number 1 of Engineering Mathematics 2 MTL 1026. In this lecture, we will discuss about what is differential equation, what are the different type of differential equation, what is order and degree of the differential equation, what is linear and non-linear differential equation, and what is the solution of the differential equation which we call family of curve, right? And how we will say different solution of the differential equation are linearly independent or dependent to each other. Okay, in this lecture all these things we are going to discuss. So let us start with what is the differential equation. A differential equation is an equation which involve derivative of dependent variable with respect to one or more than independent variable is known as differential equation, right? For example, d2y by dx2 plus 5dy by dx plus 6y is equal to e to the power x. Let us consider this example. In this example, y is dependent variable, and x is independent variable. Whereas in differential equation, dou 2u by dou x2 plus dou 2u by dou y2 is equal to sine of x plus t. Say here u is sine of x plus y, where u is dependent variable. See, new variable appears in the numerator is always dependent variable. Okay, dependent variable. X and y, these two are independent variable. Okay, so come to the differential equation. What is differential equation? An equation which involves derivative of dependent variable. So y or u, derivative of dependent variable with respect to one or more than one independent variable. Here x is one dependent variable and here x and y is more than one independent variable. If the derivative of dependent variable with respect to one or more than one independent variable involve in a in an equation, then such equation is known as differential equation. Okay. For example, let us see this example. d3y by dx3 plus d2y by dx2 plus dx by dt square is equal to e to the power t. Here, see e to the power, and this is dy by dx. Okay. So in this differential equation, y is dependent variable, x is independent variable. Okay. And in next differential equation, say k into d2y by dx2 plus 1 plus dy by dx whole square whole to the power 3 by 2. Say y is again dependent in this also, and x is independent variable. Okay. And in next example, dou 2u by dou x2 plus dou 2u by dou y2 equal to 0. Here u is dependent variable and xy is independent variable. Okay, independent variable. If such derivative involved in an equation, then equation is known as differential equation. All three are the differential equation. Even then this is also differential equation and this one is also differential equation. Okay. Now come to the type of differential equation. They basically differential equation is classified in two broad category. Number one, ordinary differential equation, and second one is partial differential equation. So basically differential equation. So differential equation is classified into ordinary differential equation, which we call ODE, ordinary differential equation, and second one is PDE, which we call partial differential equation. Okay. So what is ODE and what is PDE? Ordinary differential equation is basically a differential equation which involve a derivative of dependent variable with respect to only one independent variable, right? For example, see this differential equation. Right? See this differential equation. This differential equation, what is derivative of dependent variable? What is dependent variable? Variable appears in the numerator, that is y. Y is the dependent variable. Variable appears in the denominator, that is x, independent variable. Okay. So derivative of dependent variable with respect to single independent variable. If such derivative involved in an equation, differential equation, then differential equation is known as ordinary. Okay. And second one is partial differential equation. Partial differential equation. If derivative of dependent variable with respect to one or more than one, with respect to two or more than two independent variable. For example, dou 2u by dou x2 plus dou 2u by dou y2 is equal to e to the power x plus y. Say this. Okay. What is u? U is dependent variable. U is dependent variable. And what is x and y? This is independent variable. Independent variable. So in this equation, this is an equation. Basically, this is differential equation in which derivative of dependent variable with respect to two or more than two independent variable. Then this differential equation, this type of differential equation is known as partial differential equation. That is PDE. This type of differential equation is known as PDE. Okay. Now come to the next topic. What is order of differential equation? Okay. So order of differential equation, basically order of differential equation is the highest order derivative involved in the differential equation. Suppose in our previous example, for example, d2y by dx2 plus 2dy by dx plus y is equal to e to the power x. Say this. What are the different order derivative involved here? This is zeroth order derivative. Zeroth order. This one is first order derivative. This one is second order derivative. So what is highest order? That is second. So highest order derivative involved in the differential equation is known as order of the differential equation. So here highest order is 2. So order of this differential equation, order is 2. Okay, order is 2. So order of highest order derivative involved in differential equation is known as order of differential equation. Okay. Now come to the degree of the differential equation. Okay. What is degree of differential equation? The degree of differential equation is the power of the highest derivative which occurs in the differential equation. But the condition is that powers of highest derivative in the differential equation after making it free from radical and fractions. Right? As far as derivative are concerned, there are no radical or fraction powers appears in the derivative. Right? For example, d2i k into d2i by dx2 is equal to 1 plus dy by dx whole square whole to the power 3 by 2. Right? See this one. First example, and second one is dou 2u by dou x2, right, is equal to c square dou 2u by dou t2. Okay. So what is degree? Power of highest derivative. Right? See one more example. One simple example, d2y by dx2 plus 5 dy by dx plus 6y is equal to e to the power x. Okay. Now see, in equation 1, power of highest derivative. What is power of highest derivative? Power of highest derivative is 1. Whether in equation number 1 any radical or fraction are involved? No. So the degree of this differential equation, what is degree? Degree is 1. Okay. See here. What is power? Power is 1. But there is fraction, not 3 by 2. Now a fraction involved in the differential equation. The definition says that the power of highest derivative involved in the differential equation after making it free from radical and fractions, right? As far as derivative is concerned, means there is no radical or fraction power on the derivative. So it is 3 by 2. So this can be written as k into d2y by dx2 whole to the power 2 is equal to 1 plus dy by dx square whole to the power 3. What is degree? This degree is 2. What is degree? Degree is 2. Okay. Now come to the third equation. What are the highest derivative? Highest derivative here is 2. This is also 2. Okay. What is the power of highest derivative? Okay. So the degree of the differential equation is 1. Degree of differential equation is 1. So this differential equation of degree 1, this differential equation of degree 2, this differential equation of degree 1. Okay. So this is the order and degree of the differential equation. How we can determine the order and degree of the differential equation. Okay. Now come to the linear and non-linear differential equation. What is linear differential equation? A differential equation is called linear if it satisfies the following condition. Number one, every dependent variable and every derivative involved in the differential equation is of the first degree only. For example, suppose differential equation d3y by dx3 plus y to the power 2 d2y by dx2 plus 6y is equal to 3. Say for example, this differential equation is linear? No. What is dependent variable? Y is dependent variable. Y is dependent variable. What are the derivative? There are two derivative involved in the differential equation, d2y by dx2 and d3y by dx3. Okay. See, differential equation is linear if every dependent variable and its derivative in first degree only. See here y. What is y? Y is the dependent variable. The power of the dependent variable appears in the differential equation must be 1. Here what is the power? 2. So this differential equation is not linear. Okay? This differential equation is not linear. Suppose in case if differential equation is 1, power of this independent variable is 1. Now this is linear? No. Again this is not linear. Why? Because second condition failed. What is second condition? No product of dependent variable on and or its derivative, means no product appear y into y into dy by dx or y square dy by dx or y into d2y by dx2. Okay, except. So second condition is that no product of dependent variable and or its derivative occur in the differential equation. Now come to the second point here. Product of dependent variable and its derivative appear in the differential equation. So it is not linear also. So this differential equation neither satisfy condition 1 nor satisfy condition. So this is not linear. Okay. So what is the linear differential equation? A differential equation is to be linear if it satisfies two conditions. Number one, every dependent variable and every derivative involved in the differential equation is of first degree only. And what is second condition? Second condition is no product of dependent variable and or its derivative occur in the differential equation. Okay. So what is the example of linear differential equation? Example of linear differential equation is d3y by dx3 plus 5d2y by dx2 plus 3dy by dx plus 2y is equal to sine of x. This differential equation is linear. Why linear? See, every derivative of first order 1, 1, 1 and dependent variable of also first order. Okay, no product of dependent and independent no product of dependent variable with the dependent variable or no product of the dependent variable with the derivative involved in the differential equation. So it is linear. Okay. What is non-linear differential equation? Obviously, a linear differential equation, a differential equation which is not linear, that is a differential equation which is not linear is non-linear differential equation. Okay. Suppose if we multiply here y, now this differential equation is not linear. Okay. This is not linear differential equation. Okay. Now come to the solution of the differential equation. What is solution of the differential equation? See a simple example, right? d2y by dx2 minus 5 dy by dx plus 6y is equal to 0. See this differential equation. Now let y is equal to e to the power 2x. Now what is dy by dx? 2e to the power 2x. What is d2y by dx2? 4e to the power 2x. Right? So putting all these terms here. Okay. Then d2y by dx2 is 4e to the power 2x minus 5 dy by dx is 10 e to the power 2x 6y 6 e to the power 2x. This is equal to 0. So this function and its derivative satisfy this differential equation. So y is equal to e to the power 2x is solution of the differential equation. Solution of 1. Say this is okay. Similarly, y is equal to e to the power 3x is solution of, you can verify it, y is equal to e to the power 3x is the solution of 1. Okay. So what is the solution of the differential equation? Basically, solution of the differential equation a relation between dependent and independent variable, which we called a functional relation of dependent and independent variable, which satisfy the differential equation is known as solution of the differential equation. Okay. That is any relation between the dependent and independent variable. When substituted in the differential equation, right, it reduces it to the identity. It's called the solution of the differential equation. Okay. For example, y is equal to e to the power 2x is the solution of 1. Y is equal to e to the power 3x is the solution of 1. In general, we can write y is equal to c1 e to the power 2x plus c2 e to the power 3x is the solution of differential equation. Is the solution of 1. Right? Which we call it general solution, where c1 and c2 are arbitrary constant. Whatever constant you want c1 and c2 is satisfy differential equation. Okay, that's why this is called general solution of the differential equation 1. Okay, now what is the general solution, what is particular solution, and what is singular solution? Okay, in our last example, what is solution of the differential equation? Y is equal to c1 e to the power 2x c2 e to the power 3x. What is this? This is the solution of which differential equation? d2y by dx2 minus 5 dy by dx plus 6y is equal to 0. Okay. So this solution we call general solution. And what this general solution curve? Later on we will discuss what is the general solution. What this general solution gives us? This general solution gives us the family of curve. This general solution gives us the family of curve. What is family of curve? Okay. Let us see by the some example. Na? A n parameter family of curve is set of relation of the form xy and f of xy c1 c2 cn equal to. Okay. So this is called n parameter family of curve. What is f? F is real valued function. xy c1 c2 and cn, x and y, these are the variables. Some is dependent and independent variable, but these two are variables. C1 c2 cn are arbitrary constant. These two, these n are arbitrary constant. Okay. but these arbitrary constants have some values in the interval on the real line. Okay, so Ci, for example, Ci belongs to A. Okay, Ci belongs to A. So this is called n parameter family of curve. Let us see this n parameter family of curve by some example. If we consider x square plus y square equal to x square plus y square equal to is x square plus y square equal to c. This is the circle center at 0 0 and radius square root of c. Okay, okay, center at 0 0 and radius square root of c. Suppose c is 0. If c is 0, then what is this equation? X square plus y square equal to 0. This is 0 circle or point circle. If c is 1, if c is 1, then what is this? See the graph. If it is 0, then this. If c is 1, c is 1, then what? Center at 0 0, radius is 1. Okay. If c is equal to 4, if c is equal to 4, center is 0 0 and radius is 2. If c is equal to, if c is equal to 3, sorry, if c is equal to 9, then center is 0 0 and radius is 3. Okay. So for different value of c, for different value of c, we got many curves, and this is known as family of curve. This is known as family of curve. So generally the solution of the differential equation is the family of curve. Okay. Now see second example. X minus c1 square, y minus c2 square is equal to c3. Right? What is c1 and c2? c1, c2 is the center. Okay. And c3, c1, c2, c3. With this we got the radius of the circle. Center at c1, c2. Right? And radius from square root of f square plus g square minus 1. Yeah? Then this is the family of circle. This represents the family of circle. For different value of c1, c2 and c3, where c1, c2, c3 are the parameter. Okay. Now come to the different type of solution. What is general solution, particular solution and singular solution? If we solve a differential equation, suppose our previous example, let us consider our previous example. d2y by dx2 minus 5 dy by dx plus 6y equal to 0. What is the solution? Y is equal to c1 e to the power 2x plus c2 e to the power 3x. This is the solution of the differential equation. Okay. You can verify it. This is the solution of the differential equation where c1 and c2 are arbitrary constant. Okay. If the solution of the differential equation contains as many arbitrary constant, how many number of arbitrary constant? Number of constant is equal to 2. And what is the order of the differential equation? Order of differential equation is 2. If the order of differential equation and number of arbitrary constant is same, then this type of solution is known as general solution of the differential equation. Okay. So this function of x, y, y1, y2, yn equal to 0 be the nth order ordinary differential equation. This y1, y2, yn denote derivative of the y. y1 is the first derivative, yn is the nth derivative. So if the solution of this is basically what? This is differential equation. This is differential equation. If we find the solution of differential equation 1 and it contains as many arbitrary constant as the order of the differential equation. What is the order of differential equation? If suppose Solution of this differential equation is the family of curve small f pxy c1 c2 cn equal to 0. Okay, how many arbitrary constant? N arbitrary constant. N arbitrary constant. What is the order of differential equation? If the arbitrary constant and order of differential equation are same, then this solution, this family of curve, represents the general solution of the differential equation. Okay. Next, what is particular solution? A solution of one is obtained from the general solution by giving the particular value to one or more than one arbitrary constant. For example, say this differential equation. If we consider C1 is equal to 0 and C2 is equal to 1, then what is y? Y is equal to e to the power 3x. Right? This is the solution. Of course, this is the solution of the differential equation, but this is obtained by assign a particular value to the arbitrary constant. So this solution is known as particular solution. What is this? This solution is known as particular solution. Okay. And what is general solution? What is similar solution? A solution of one which cannot be obtained from the general solution by any choice of the arbitrary constant. By any choice of the arbitrary constant. Right? A solution which is not obtained by any choice of arbitrary constant C1 and C2, Cn. Okay. Then such solution is known as singular solution. For example, consider dy by dx whole square minus 4y equal to 0. What is the solution? Y is equal to x plus c square. Okay. What is the order of differential equation? 1. Then y is equal to x plus c square is the solution of the differential equation. And number of arbitrary constant and order are same. Therefore, this solution is the general solution. But what about y equal to 0? Y equal to 0 is the solution of this differential equation. dy by dx square minus 4y equal to 0. Right? This y equal to is the solution of this differential equation. The solution of this differential equation. But this y equal to 0 cannot be obtained from this solution by any assigning c any value, whatever you want. Now, here c, what is c? C is arbitrary constant. Whatever constant you can put here, this y cannot be 0. So y equal to 0 cannot be obtained from the general solution after any choice of c. So y equal to 0 is also a solution, but this solution is known as singular solution. Okay, this is the singular solution of the differential equation. Okay. Now see, y is equal to c1 e to the power x e to the power 2x is the solution of the differential equation. Single solution since number of arbitrary constant and order of the differential equation are same. Okay. If we put c1 is equal to 1, c2 equal to minus 1, then these solutions become this one. And this becomes, since c1 is 1 and c2 is minus 1, so this dual solution become particular solution. And third example is same, y is equal to x plus c square is the solution of differential equation. But y equal to 0 cannot be obtained from another. So y equal to 0 is the singular solution of the differential equation. Okay. Now come to the next topic. How we can determine if two or more than two solutions of the differential equation are dependent or independent to each other. Right? That we can determine by the Wronskian. What is the Wronskian? Suppose, let us again consider our previous example. Okay, d2y by dx2 minus 5 dy by dx plus 6y is equal to 0. E to the power 2x and e to the power 3x. Say it is y2x and say it is y. Okay, so there are n functions. Here two functions, n functions y1, y2 up to yn. Right? Then their Wronskian is denoted by simply wx are W of y1, y2, yn. Okay. And what is this Wronskian? It is nothing but determinant. Determinant of what? Y1, y2, yn. First row. First derivative is the second row. Second derivative is the third row. Right? It is zeroth derivative. Zeroth derivative. This one is first derivative. This one is second derivative. Yeah, that's one. And this one is n minus 1th derivative. Okay. So nth row is the n minus 1th derivative. First row is the 0th derivative, second row first derivative, and nth row is the n minus 1th derivative of y1, y2, yn. Construct this determinant and solve this determinant. If this is equal to 0, then solutions are dependent. If this is 0, then solution is dependent. Now come to this example. E to the power 2x, e to the power 3x. What is first derivative? 2e to the power 2x. What is first derivative? 3e to the power 3x. Now solve the determinant. 3e to the power 5x minus 2e to the power 5x. What is this? E to the power 5x. This is not equal to 0. Okay. So these two solutions are linearly independent. These two solutions are linearly independent. Okay. Similarly, let us consider this example. Suppose this differential equation is given and solution is this one, ex sin x, ex cos x. What is the general solution? Basically, the general solution are obtained by C1 into first particular solution and C2 into second solution. Okay, so this one becomes general. Why? Since the arbitrary constant is 2 and order of differential equation is 2. So this one is the general solution. So general solution is C1 e to the power x sin x, C2 e to the power x cos x. The general solution. Okay. Next, find the solution yx which satisfy this condition. Okay. Let us say y1 is this one and y2 is this one. Okay. Then they are dependent or independent to each other. So calculate their Wronskian. Ex sin x, ex cos x. This is the first row, and their derivative of this. After solving this determinant, we got minus e to the power 2x. This is not 0. So these two solutions are linearly independent. Which are linearly independent. And what is general solution? C1 into first one, C1 into y1, C2 into y2. After simplifying, we got y is equal to this. This is the general solution. Okay. Now apply the condition. Whatever with the condition that is given, y0 is equal to something and y prime 0 equal to this. Y0 equal to 2 and putting y0 means x is equal to y in above equation. Okay, we got C2 is equal to 2 and y prime, calculate y prime 0 is given by minus 3. So x is equal to 0 and y prime is equal to minus 3. Solve this gives us, sorry, this is C1 not C2. This is C1 and C2 is equal to minus 5. So put the value of C1 and C2, you got the particular solution. This is particular integral. Okay. Okay. In next topic, we will discuss about how to solve the first order first degree linear differential equation. Okay. First order first degree linear differential equation.